Now let's look at the same example as the previous video. And this time we want to use the Simtable method. Okay, Simtable, remember, it runs the simulation model, okay, for a given input value. Okay, it could be decision variable, then repeats it for a second possible value, repeats it for the third possible value, and so on. Okay, here suppose we want, okay, in previous example we assumed that the average demand will be a PERT distribution with these given values for minimum, most likely, and maximum. But suppose that we want to do a sensitivity analysis between possible demand distributions of either PERT or normal distribution. Okay, and say normal distribution mean of 200 and standard deviation of 40. Okay. Normally, you would rather look at the actual data, try to fit a probability distribution for a given data set, and we will look at an example like that in the next or in one of the future chapters. And when we try to fit a probability distribution to a data set, at risk will suggest the best fit, the second best fit, and the third best fit, and so on. So sometimes numerically the best fit may not be theoretically the best fit for our data. Our experience may tell us that, okay, no, that's not the ideal distribution. Maybe we want to try a different one. Okay, so of course we don't want to try a probability distribution that's completely off the chart. Okay, we want something that is a reasonable fit. Okay, even if it is not the best found by at risk. Uh, so so with that in mind, let's say that we want to try the simulation once with PERT and then with normal distribution, and then see what the differences are and try to understand how sensitive our profit is to the kind of demand distribution that we assume. Okay, so now how do we set the demand distribution to this one time and this the second time and automate the process in at risk? Okay, I'm sure there are several ways this can be done, but I'm going to show you one way, and that is we're going to do a simulation of either PERT, that will be the first simulation, and the second simulation would be normal. Okay, so we want to set this demand probability distribution to PERT if the simulation number is 1, and if the simulation number is 2, we want to set that to normal distribution. So I'm going to insert a couple of rows here. Okay, and then we say demand distribution, and do a risk sim table. Okay, so you can type. The last time we used risk sim table, we went to at risk, and then we did function and miscellaneous, and then selected risk sim table. And we can do that, or we can simply type like we type in Excel functions, and then it will prompt you as you type, and then once you have what you're looking for in the list, then you just select it. Okay. Now risk sim table, we want these two to be set as the demand distribution here. So when you run at risk, okay, at risk will enter the first value, run the simulation, and then it will insert the second value and then run the simulation again. So this cell B14 is going to be either 1 or 2. Okay, in the first time it will be 1, the second time it will be 2. So now we can use that to set the probability distribution. So you can say if this is equal to 1, then we're going to do a risk but, right? And then minimum, most likely, and maximum. Okay. Otherwise, if it is not 1, then it's going to be risk normal, and you need to specify the mean and the standard deviation. And then we close parenthesis for the if. So now we have a demand. So first time around, when it is 1, it will use that. Second time, it will use that. And suppose we want to make this whole number, then you add round 0. Okay. Now we want this to be the output cell. Okay. Then let's set up order quantity to be 200. Okay, so that's that. Okay, so now the model is ready. Now we can run the simulation, and this time we need only 2. But if you run only 2, we ran 5 simulations in this sheet. So it's a good idea to not have more than one at-risk model in a given file. But I have more than one model because I want to have it all in one Excel file. And because of that, if I change this to 2 here, the 3, 4, and 5 will get messed up in this sheet. So I'm going to run 5 times, even though I need only 2 for this sheet. Okay, now it's completed. Now we can set up the statistics that we want from the run risk min of profit. All right, and I'm going to make it absolute reference so that we can copy it over to the second simulation. And the first simulation with PERT is that. Then risk percentile. Okay, again profit absolute reference. Now we want 5% for the first simulation, and then we want risk mean, again profit absolute reference for the first simulation. And then percentile, I just copy paste that, go into edit mode, copy with Control C, and then go into edit mode here, and then enter with Control V, change that to 95%. Okay, and then risk max. Okay, that should be absolute reference for the first simulation. And then we want standard deviation risk STDEV of profit. Okay, absolute reference that, and 1. Okay, so they are all in dollars. Change that to dollar, and we don't want any decimal places to be displayed. Okay, so now you see that if the demand has a normal distribution, then it has less risk. Standard deviation is 175, whereas standard deviation for PERT distribution is standard deviation of profit is 195. Yeah. And the statistics here, okay, so on the positive side, on the optimistic side, the profits are about the same. That's because we have 200 as the fixed order quantity. We probably want to do some analysis on that too. Do another sim table for this, and then on the left side, okay, normal distribution has a higher loss possibility at the minimum. Okay, but the fifth percentile, okay, if that's what is you're interested, then it looks like, under the case of normal distribution, loss is less than 5% possibility.